All right, guys, let's jump right in. You should have page 5, properties of matter, and you should also have a highlighter and something to write with. So don't forget to write your name up here so that when you take a picture of it and submit it, I can see your name. Okay, so matter. Matter is anything that has mass and takes up space. Mass is the measurement you make using a balance, okay? And it's usually in like grams or kilograms, milligrams, okay? States of matter. So we're solid, liquid, and gas. Those are the 3 states of matter we're going to worry about this year. Okay, a solid has a definite volume and a definite shape. Okay, so here's a solid right here. It's ordered, meaning there's like a, there's order to it. It's not mixed up like this. It's like in straight rows, okay? Has definite shape and volume, meaning it doesn't matter what container you put it in, it's going to maintain its shape and its volume. And it says solids are very slightly compressible. Let's just cross that out because we're going to learn that really for all intents and purposes of 8th grade chemistry, gases are the only ones that we're going to consider compressible, okay? A liquid has definite volume but indefinite shape, okay? So if you put a liquid in a new container, its volume is going to stay the same, but its shape will change, right? It assumes the shape of its container. So here's a liquid. It's also, it is disordered, meaning it's not in straight rows. Less dense, has definite volume, takes the shape of the container, and it says liquids are slightly compressible. Okay, so while that's true, it's very, 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 very slight, so we're not even going to worry about that. And the last one is a gas or a vapor. Okay, they have neither definite volume nor definite shape. Okay, neither definite volume nor definite shape. It assumes the volume and shape of its container. Disordered, also much lower density than crystal or liquid, crystal meaning solid or liquid. And gases are highly compressible. So when we're talking about what's compressible, again, for 8th grade chemistry, we're saying gases are the only ones that are really compressible. These ones are slightly compressible, but it's very, very, very slight, and these ones are almost not compressible at all. Very, very, very hard to compress. Okay? Okay. Let's fill this in real fast. So I've got solids, liquids, and gases. So let's talk about the shape and volume properties of solids. So we already said it has a definite shape and volume. Okay? Whereas liquids have a definite volume, indefinite shape. Okay, their shape can change based on the container that they're in. And gases are indefinite volume and shape, right? The shape can change, the volume can change, it all depends on the container that the gas is in. Okay, movement of particles. Solids have very little movement. Very little movement. The particles might vibrate. Oops, little movement. But they're pretty much going to stay put for the most part. Liquid, the particles slide past each other. They slide past each other. Okay? And in a gas, very fast-moving particles. Okay, fast-moving, bumping up against each other constantly, bumping up against the walls of their container. Quick, quick, quick. Okay, arrangement of particles. In a solid, they're packed closely together. Packed closely together. And they're in a regular pattern. Okay, regular arrangement. Regular pattern. Now, liquids are close together. Close together. Sorry about my handwriting, guys. You will learn that I am not known for my beautiful handwriting. Close together, but there's no regular arrangement. No regular pattern or arrangement. Disordered. That says arrangement. And gases are well separated. Well separated. Okay? There's lots of space between those particles. So lots of space between the particles, okay? Lots of space between them. Compressible, we said no for solid. No for liquid, yes for gas. So what that means is if you were to take those gas particles and you were to squeeze them, they are able to squeeze into a smaller container. Okay. Whereas a liquid and a solid, you could push down on the lid of the liquid and it's not really going to compress. Now in certain laboratory settings, it is found that liquids are very slightly compressible, but again, for the macro level we're looking at in 8th grade chemistry, we're just going to say these are not compressible. Gases are the only ones that are compressible for the most part. Okay. Changes of state. So if you have a solid changing to a liquid, we call that melting, right? Okay. A liquid changing to a vapor, we call that evaporating, right? Or vaporizing. Vapor or gas changing to a liquid, that is called condensing, like condensation, condensing. Okay, like when you get a cold drink and there's liquid on the outside of the drink, that liquid that's on the outside of the drink, that came from the air around it. There's water in our air, especially here in Texas, right? It's a little humid here. There's water in our air. When that water in the air hits the cold glass of your drink, it condenses and it goes from a gas in the air to a liquid, and it sticks to the side of that cold drink. Okay, that's what condensation is. A liquid changing to a solid, that would be freezing. A solid changing directly to a vapor without going through the liquid phase, that is like dry ice. That's called sublimation. Not super common, but it happens. And the other way around is deposition. Deposition. Okay, an example of a vapor changing directly into a solid would be if you ever have, I know we don't see this too much in South Texas, but a frost on your windshield when you get in your car in the morning during the winter. That's because, again, there's water in the air, water vapor in the air in the gas form, and when it hits your cold windshield, it can freeze directly into a solid. That's deposition. Okay, triple point. I just want to point out what this is. Triple point is, so when we increase the temperature, things tend to go from solid to liquid to gas, right? But it also depends on pressure. Pressure is also, it plays a part in it. And we'll talk more about that towards the end of the year when we get into gas laws and things like that. But there's a point at which solid, liquid, and gas phases can coexist. And if you're really interested in seeing what this looks like, just go to YouTube and type in triple point or triple point demo, and you can kind of see what that looks like there. And I just wanted to make you aware that does exist. So there's a point at which, a solid turns into a liquid, and it depends on your pressure and your temperature. And there's a temperature and a pressure at which all three of these kind of states of matter can kind of exist at the same time. It's kind of cool. So let's flip over to the back. Physical properties. We're going to talk about physical properties and chemical properties. So physical properties are here. Chemical properties are here. Physical properties. Describe the substance itself. So they can be observed or measured. Observed or measured without altering the chemical identity of the substance. Okay? That's important. That's what makes it a physical property versus a chemical property. Physical properties are further broken down into either extensive or intensive properties. Okay? So extensive properties and intensive properties. Extensive properties depend on the amount of matter present. Okay, these properties vary with the amount of substance present and therefore cannot be used to uniquely identify a substance. Okay, so we're going to label which of these physical properties are considered extensive, meaning it doesn't matter if you have a lot of it or a little of it, it's not going to change that property, basically. I mean, it is going to change that property. Sorry, I said that backwards. It depends on the amount. So extensive properties, if you have a lot of it or a little of it, it will change. So these ones are your extensive properties. Mass, length, and volume. Okay, if you have a lot of, I don't know, pick a random, like copper, for example. If you have a lot of copper versus a small sample of copper, its mass is going to be different, its length is going to be different, its volume is going to be different. Now, intensive properties are the opposite. These properties do not depend on the amount of matter present. These properties stay the same. Regardless of the amount of substance present, and therefore they're frequently used to uniquely identify a substance. Okay, so for example, boiling point. I don't know if you guys knew this, but boiling point is an intensive property, meaning it doesn't matter if I have a lot of water or a little bit of water. Pure water will boil at 100 degrees Celsius. It doesn't matter how much I have. Now, it might take longer to get to 100 degrees Celsius if I have a whole bunch of water, but the boiling point is consistent. Okay, color, that's another thing. If I have a sample of copper that's this big, a sample of copper that's this big, the color is the same. The color doesn't change based on how much I have. Same with the ability to conduct electricity. And density is another one. People forget that density is intrinsic. It's just a ratio of your mass to your volume. Density is something that I could Google. I could Google, hey, what's the density of copper? And Google will tell me what the density of copper is because it's how dense it is. It doesn't matter how much I have. So that's kind of something I like to remember with intensive properties, is if it's something you can Google, it's intensive. Can I Google, hey, what's the boiling point of, isopropyl alcohol? Yeah, I can Google that. Can I Google, hey, what's the color of, I don't know, cobalt? Yeah, I can Google that. So that's an intensive property. Can I Google what's the mass of cobalt? No, I can't Google what's the mass of cobalt because it depends on how much cobalt you have, right? So that's what makes it extensive. So let's talk about chemical properties. Chemical properties describe the ability of a substance to undergo changes that transform it into a different substance. So again, physical properties can be observed or measured without changing the chemical identity. Chemical properties, if you were to observe or measure a chemical property, like these chemical properties here, then it would alter the chemical makeup of that substance. So let's look at this fun little activity here. It says, consider the following properties for the metal sodium. Okay, and it asks us which ones are extensive, which ones are intensive, and which ones are chemical. So first, let's look right here. It says sodium is a soft silvery colored metal. Okay, let's stop there. Soft. It is soft. Okay, well, I can observe that without changing it, so that'd be physical. Now, does it matter how much I have? If it's a lot or a little bit, is it going to be still soft? It's still going to be soft. Doesn't matter how much I have. So that'd be an intensive property. So number 1, soft, I'm going to put under intensive. It says silvery colored. Again, that's color. We decided up here that color is an intensive physical property. So we're going to put number 2, silvery colored, under intensive as well. Okay, it has a density of 0.97. Density is also intensive. Okay, it says when a 2-gram sample of sodium. So 2-gram sample, that would be mass. Okay, so that's a physical property, but it's an extensive physical property because it will change. Okay, so right here. There we go. It burns with a yellow flame. Okay, if it burns in a yellow flame, that you can't burn something and find out the color of the flame without changing it chemically. So that's a chemical property. And it reacts vigorously with chlorine gas to form salt sodium chloride. Okay, so that's changing the chemical makeup. That's also a chemical property. And then it says sodium melts at this temperature and boils at this temperature. Melting point and boiling point are both intensive physical properties because you can melt something. So that'd be number 7 and number 8. You can melt something without changing its chemical makeup. If I take some water and it's ice, it's frozen, and I melt it into liquid water, is it still H2O? Yeah, it is. It's still H2O. So that's what makes it a physical property, intrinsic physical property. Okay, physical and chemical changes. A physical change does not change. So these are changes versus properties. A physical change does not change the identity. So that's what I was just talking about with melting some ice. If I melt the ice, that's a physical change because it doesn't change the fact that it's H2O. So changes of state like melting, freezing, etc. are all physical changes. I'm going to highlight that. Are all physical changes. So changes of state are physical changes. Most physical changes are reversible. So I could take that water that I melted and I can put it back in the freezer and freeze it again. It's still going to be H2O, okay? Chemical changes transform one or more substances into different substances, okay? A chemical change means it's now a new and different substance, okay? And here are some ways that we can know if a chemical change has happened. These are the 5 ways we can know if a chemical change has happened. First is a change in energy. Basically, if we see heat or light produced, meaning like the temperature change, I'll just put that over. Temperature change, light's produced, you see fire, flames, stuff like that. Okay, next one is a gas is produced. If you see a gas produced through either like a vapor coming off of it or you see bubbles forming, that probably means a chemical reaction or a chemical change is happening. If you see a color change, that could be an indicator that a chemical reaction is happening. A new smell, or if a solid is formed. Now, if you remember in chemistry class, there's a word for that. When a solid forms in a chemical reaction, we call it a precipitate. I don't know if you remember that from last year. Precipitate. That's just a fancy word for a solid that's formed in a chemical reaction. Okay? And here is a list of words that describe physical changes. So bending, boiling, melting, subliming, condensing, grinding, cutting, depositing, dissolving, freezing, vaporizing. Those are all physical changes. Most of them are reversible or they don't change the chemical makeup of the substance. Whereas chemical changes, here's some chemical changes: tarnishing, burning, exploding, reacting, rotting, rusting, corroding. All of those things are chemical changes. They change the chemical makeup of whatever substance you're working with. Okay? All right, that's it for these notes. Go ahead and snap some pictures of them and do the assignment. And send me a chat if you have any questions.